So, example 4 here, we are continuing on with 8.4 logarithmic functions, and let's take a look here. The slope S of a beach is related to the average diameter of sand particles in the beach by this equation. Find the slope of the beach if the average diameter of the sand particles is 0.25 millimeters. What this is saying is D is 0.25, that's the diameter, so all I'm doing is plugging that in. What I want you to realize is how to type in log. So go on your calculator, and right beside the 7 on your graphing calculator there's a log. So press log and 0.25 and parentheses, and when you do that you get negative 0.602. Okay, when you're doing that, when you get negative 0.602, that's as easy as typing in logs really is. And we're going to get into some more deeper logs here to type in a second, but that's all you need to do for typing in a log. And just type that all in on one shot on your calculator, and you get approximately negative 0.23. For example 6, it says find the inverse. Well, find the inverse means rewriting that, which means you take the base, you write it to the answer. So the base to the answer is 3 to the y equals whatever's left over, which is the x. Then all you need to do is switch the x and the y, so you get 3 of the x equals y. That's all that finding the inverse is. Okay, all that finding the inverse is just rewrite it in exponential form and flip your x and y. The natural log, this is the first time you're seeing the natural log, that's ln. Okay, and on your calculator that's right below the log. The opposite of a natural log is e. Okay, those two things are opposites of each other. So whenever you see a natural log, basically to get rid of the natural log, you need to take it to the e power. So notice how this went up to the e and this all went up to the e. So basically I put an e underneath both of those and changed those both into powers. But e and natural log are the opposite of each other. So whenever you see e and the natural log together, you can cross those right out. So all that you have left over on that side is x plus 1. So you have e to the y equals x plus 1. Sometimes people actually think that the natural log is easier to switch because it has the e there than the logarithm is. So once again, you subtract 1 on both sides, and we have that solved for x, but we have to switch the x and a y when we're talking about inverses. So we end up with e to the x minus 1 equals y. That's the inverse. So remember, at the very end, just switch your x and your y around. Graphs of logs. So when we're talking about graphing logs, here's the form of graphing a log. You have a little base b, alright, which is used to being your base. That's your x minus h plus k. The same formula as we've been doing before. It follows the same characteristics of everything else. The line x equals h, that's a vertical asymptote. So right here, in all the exponential functions, we were talking about horizontal asymptotes, which went straight across. In logs, this negative h, that's your vertical asymptote. That means it's going up and down. Okay, and the domain is x is greater than h, and the range is all the real numbers when you're talking about logs. Okay, if b, your base, is greater than 1, the graph moves up to the right. If b, your base, is a fraction, it moves down to the right. So keeping those little things in mind. Really what I'm mainly concerned with you guys right now is that you can type this in on a calculator. Okay, this will take a little bit of time to type it on the calculator. Whenever you have a log of the 1/3, log base 1/3 x, when you're going to type something like this in, takes a little more time to plug in. So when we're doing this, make sure that you type it in as the top over the bottom. So what I mean by that is, I want you to type in on your calculator, go to y equals and clear it all out, press log. You take the log of the top, which is x, so it's log x, right, log x, then end the parentheses, then divided by, then do a log on the bottom, and then do 1/3. Okay, that's saying that's the only way you can type in logs to graph them. You got to do the log of the top over the log of the bottom, and then we have afterwards a minus 1 at the end. So when you go and press graph, your graph kind of looks like it's going like that, running right down off to the side. So let's see what we get. Second graph, when we go and type it in, let's figure out what we get for negative 2. When we plug in a negative 2, we am getting undefined. It says error there. When I plug in a negative 1, it says error again, it's undefined. When I go to 0 on my list, it says error again. The reason it says error is because you can't plug those numbers in. But I can plug in a 1. When I plug in a 1, I get negative 1. When I plug in a 2, I get negative 1.63. So when I go to graph that, it means I go over 1 and up negative 1. Or sorry, I go over 1 and down negative 1. Then I go over 2 and down negative 1.63, which is right there. And there's more points. 3, negative 2 is a point, so I can go over 3 and down negative 2 and put another point there. That's another point I can put in there. And I connect it. And the reason why it goes to 0 is your horizontal asymptote. Notice how at 0 and negative 1 and negative 2, there's nothing there. That's the horizontal asymptote. That means it goes till it gets to x equals 0. Or sorry, not horizontal. It's the vertical asymptote because it goes to x equals 0. So this is the vertical asymptote right here. It goes to 0, right, but it never quite touches ever. So example 7, when I go to plug this in on my calculator, you go to y equals and clear all that out. So let's do log of the top. Log of x plus 2, so type in an x plus 2 in parentheses, divided by log, so you type in a log again with a 5. So when you go to graph, we see what that looks like. That kind of starts somewhere here and it goes up. So go to second graph, let's see what we have here. And when I go to type in negative 2, look on your list. Negative 2 is undefined. There's an error there. But at negative 1, we have 0. At 0, when you plug that in, you get you get 0.43. 1, when you plug that in, you get 0.68. And 2, when you plug it in, you get 0.86. So when I go to graph this, I can't graph anything at negative 2. But at negative 1, I can graph 0. At 0, I can graph 0.43, which is pretty close to a half. At 1, I can graph 0.68, which is a little over a half. And at 2, I can almost touch the 1, but not quite. And there's the line. Now, the reason why I know it gets really close to negative 2 is, 1, it's undefined there. It doesn't go past negative 2. But also, look up here. Whatever makes this 0 inside the parentheses, right beside the x, that's what your vertical asymptote is. Negative 2 plus 2 is 0. So whatever makes that 0 is your vertical asymptote. So keep that in mind when we're going over the problem. So at x equals negative 2 is the vertical asymptote, meaning it gets really close but it never quite touches it. So there's your homework for tonight. If you have any questions or concerns, please feel free to email me with those questions.